Okay, so we're saying that in case we have, they told us treat it as ideal gas. For the ideal gas, what are the specific equations that we are used? We can say that P and V are related through PV equals to RT. Plus, since it's an ideal gas, UH will only be function of temperature. Okay. بينما بالincompressible model, since also it's a gas, we said U and H only function of time, but because it was incompressible, we considered that V is constant. Here in the ideal gas model, the difference is that we can relate P and V through PV equals RT. Now, if you want to use the first equation of TDS, what is TDS? TDS is equal to DU plus PdV. Okay. Now, if we want to evaluate ds, we can take t to the other side. So we get, so if you take t to the other side, you get that ds is du over t plus p over t dv. Now, what can we do here? First, we said we can replace du by cv dt. So we replace du by cv dt. And since here the variable is the specific volume, we'll replace P over T from the ideal gas law by what? If you go to this relation, what is P over T? P over T is equal to R over V. R is a constant of the gas, okay? And V is the specific volume. So if you do this, what do you get now? You get the following equation, okay? So if you integrate for ds here from point 1 to point 2, you should integrate here from T1 to T2, and here from specific volume 1 to specific volume 2. And you know that what is the integral of 1 over V dV? It's ln. Yani this term will give you, the integral here will give you R ln V2 over V1. While for this term, if you have C function of temperature, you should have the function to integrate. And if they tell you treat C as constant, you can take it outside of the integral, okay? And say that I do C integral dt over T, which is ln T2 over T1. So here also we have two cases. If we have C variable or if we have C constant. If we have C variable, this is the relation we can write. If we have C constant, we can reduce this also to CV times ln T2 over T1. Now, for this side here, for this side, okay, you have that ds is equal to dh. هلا عم نستعمل تاني formula انه TDS is equal to dh minus VDP, okay? And now we take T to the other side, so بتصير ds equal dh over T minus V over T dP. And according to the ideal gas law, what is V over T? V over T can be replaced by R over P. And now if we do the integration from state 1 to state 2, we get that S at state 2 minus S at state 1 equals to integral from T1 to T2 CPT dt over T minus R integral of dP over P is ln, يعني minus R ln P2 over P1. هلا بتقولوا لي أيها بنستعمل؟ It depends on what? It depends if you know the pressure at state 1 and pressure at state 2, or the specific volume at state 1 and state 2. يعني إذا أنتم بتعرفوا we go from pressure, which pressure to which pressure, أكيد بتستعملوا this formula. And if you know how the volume is changing, and you can calculate the specific volume at state 1 and the specific volume at state 2, you use then this relation. So depending on the given, you select which relation to apply. Any question on this?
Yes, دكتور سؤال.
Yes, tell.
هلا للفاينل بخصوص الفورمولا شيت.
Yes.
احنا بنحفظ كل فورمولات هذا الشابتر او في شيء
We will give you the formula sheet before. We'll post it on e-learning, okay, to see which formulas you have. But please, you should understand things. يعني احنا we give you the complex formulas, but هول simple ones, you should know how to get them. خصوصي مثلا delta H equals CP delta T, and this is a basic formula that you should know. هلا we'll post for you the formula sheet to know which formulas you have. Okay? So
Okay.
now,
Merci.
welcome. As we discussed together, okay, in
بس
general,
دكتور مش نحن بنطبعها مش صح؟
no, you don't print anything. Everything will be in the provided for you within the exam. You don't have to bring anything with you.
دكتور
Yes.
وللفاينل عنا من ال1 لل6.
هلا mainly عادة it's cumulative, بس إنه of course we focus on last chapters. Okay.
اوكي يعني 4 5 6 اكثر شيء.
Yes.
اوكي وبالنسبه للجريدز في شيء ظبطتيهم انه في داعي نذكرك ولا؟
No, I did.
اوكي ثانك يو.
دكتور كمان periodic table sorry مش periodic tables تبع thermodynamics
Will be provided. You don't bring anything with you. Okay.
okay
Now, as we discussed together, you have that C, the specific heat will be function of temperature. So, or they should give me the function to integrate, or they can give the results in tabulated form. Yani they perform the integral for me, and they give me them in tables in order to avoid extra calculation from my point. Okay? شو فكرة هالcalculation؟ هن قالوا إنه let us select a reference temperature. We can select any reference temperature, T prime, okay? And we evaluate the integral from T prime to T of Cp over T dt. ساعتها أنا, if I want to compute S2 minus S1, شو فيني أعمل? I can evaluate first the integral from T prime to T2 minus the integral from T prime to T1. اوكي لانه انتم بتعرفوا بالانتجرال if you do this T prime will cancel out صح؟ لانه you can replace minus integral T prime from T prime to T1 by plus integral from T1 to T prime. اوكي وانتم بتعرفوا if I add the integral from T1 to T prime plus from T prime to T2 بيطلع لي T prime will cancel out, بيطلع لي ساعتها الانتجرال directly from T1 to T2. So from here the idea that I can in a table give the values of integral from any temperature T prime. So they select an arbitrary reference temperature and they provide us integral from T prime to T of this function. And therefore, I don't have to perform any integration. I go to tables. So if I have to evaluate integral from T1 to T2 of Cp dt over T, I can decompose it into integral from T prime to T2 of this function minus integral from T prime to T1 of this function. So if I go to the table, I just get S0 T2 and S0 T1. يعني هيدا symbol S0 هو represent the integral from the reference T prime. Okay. So now
دكتور شو هي الاس زيرو؟
اوكي شو هي الاس زيرو؟ نحن مش قلنا انه بده التيبل بدها تعمل لي الانتجريشن فانا ما اضطر اعملها. اوكي هيدي الانتجرال عم نقوا ريفرنس تمبرتشر تي برايم يعملوها منا. يعني انت بدك تعملي انتجرال فروم تي 1 تو تي 2 بس بالتيبل ما رح يجي يقول لك انه بدي اعمل فروم تي 1 تو تي 2. يعني مش رح يجي يقول لك فروم 200 تو 300 قد ايه لانه ما بتخلص بيصير عندك انفينيتي اوف كومبينيشنز صح؟ ما يعمل هيك شو عمل؟ قال انا حنقي ريفرنس تمبرتشر. يعني مثلا تنقول قال انا حنقي الريفرنس تمبرتشر 100 وراح اجي احط لك بالتيبل الانتجرال from 100 to any temperature. يعني from 100 to 200 from 100 to 300 etc. ساعتها انت اذا بدك الانتجرال from 200 to 300 you can do it in this way. You can say لانه في property بالماثيماتكس بتقول انه integral from t prime to t2 minus integral from t prime to t1 هي equal to integral from t1 to t2. اوكي يعني هيدي الزيرو قصدهم فيها انه نحن نقينا حيلا temperature of reference اللي هي t prime وعملنا الانتجرال منها. ساعتها انا اذا بدي اعمل الانتجرال من t1 ل t2 شو بعمل؟ بجيب S0 at T2 بعمل minus S0 at T1. اوكي، وين عندكم اياهم بالتيبلز؟ عندكم اياهم اذا بتروحوا على التيبلز 22 23. اوكي، بتلاقوهم، رح فرجيكم اياهم هون. هلا بنعمل اكزامبل عنهم. يعني if you go to table A22 في column بدل S بحطوا لكم S0. ساعتها انتم بس بدكم تجيبوا S2 minus S1 بدكم تعملوا S02 minus S01. اوكي؟ So here when you use these tables you can then replace مش نحن قلنا we want to perform هيدي الانتجرال. اكيد يعني بدنا نزيد عليها اي ترم زياده على S0 T2 minus S0 T1. بدنا نزيد this term. ليه؟ لانه what is delta S S2 minus S1. مش نحن لقينا انه S2 minus S1 هي equal to integral CP times dt over T minus R ln P2 over P1. اوكي، هيدا الترم minus R ln P2 over P1 بتجيبوه by calculation لانه انتم بتكونوا بتعرفوا P1 وبتعرفوا P2. بيبقى عندنا لانه C variable قلنا بدنا نعمل integral. بما انه طب ما نقعد نحن نعمل integral بدل ما يعطونا الفانكشن to integrate، عملوا summary للريزلتس بتيبل. يعني اخذوا reference temperature وهن عملوا الانتجرال from this reference temperature to any other temperature. That's why I can replace the integral from T1 to T of Cp dt over T by S0 at T2 minus S0 at T1. هول بجيبهم S0 بجيبهم من التيبلز. هلا بنشوف انا وياكم كيف. اوكي،
بس
مثل
دكتور
ما
ما
في
بتزبط بهيديك الفورمولا مش هيك؟
اي فورمولا
تبع السي في.
بتزبط بالسي في، بس كمان السي في لها انتجرال. يعني انت اذا قالوا لك سي بي كونستنت شو بتعملي؟ بتطلعي سي بي لبرا، بتصير عندك سي بي انتجرال دي تي اوفر تي. ساعتها ما بتروزي التيبل. ليه؟ لانه دغري بتكتبي انه شو الانتجرال؟ الانتجرال هي سي بي لن تي 2 اوفر تي 1. اوكي، بس انت مش على طول عندك سي بي كونستنت. اذا قالوا لك سي بي فاريبل ما بيعود فيك تعملي هيدا الاسامبشن، هاي السمبليفيكيشن. should perform the integral. وتتعملي انتجرال بدك سي بي function of temperature. اوكي، بما انه هن بيعرفوا كيف سي بي vary with temperature، طب ما تقعدي انت تعملي انتجرال. they did the integral and they summarized the result in a table. اوكي، يعني بس يكون عندك specific heat variable تستعملي التيبل تجيبي الانتجرال. هلا السي في كيف تستعمليها؟ السي في بغير كونتكست بتاني فورمولا. انت بتاني فورمولا وين في this one. if you go back to the equations انت you can write ds in two ways. or ds هي cv dt over t plus r dv over t او ds equals cp dt over t minus r dp over p. اياها بتستعملي مثل ما قلنا حسب شو بتعرفي عن state. اذا انت بتعرفي t1 و t2 وبتعرفي v2 و v1 بتستعملي هاي الفورمولا. بينما if you know البريشر p1 و p2 والتمبريتشر t1 و t2 ساعتها تجيبي دلتا اس بتستعملي this formula. اوكي، هلا نحن we are discussing هيدي الانتجرال كيف نجيبها. لما يكون عم نشتغل نحن على بنعرف p1 و p2 بدنا نروح على التيبل نجيب انتجرال cp dt over t. هيدي الانتجرال هي الزيرو 2 minus الزيرو 1. اوكي، وعندك كمان in case في ريليشن ثانيه مفروض تكون لا سي في، يعني الانتجرال سي في دي تي اوفر تي كمان بيكون في لها corresponding tables. بس نحن بنعرف اوكي انه حسب الكيس اللي عندنا اياه، يعني حسب اذا عندنا البريشر او عندنا الفي شو نستعمل. اوكي، يعني now in this table نحن بلشنا بالكيس اوكي انه عم نشتغل بالفورمولا تبع البريشر، يعني we need CP. اوكي، this is why التيبل عطينا انتجريشن، يعني عطينا دغري هالانتجرال بدون ما نحن نعمل لها كالكوليشن. ونقوا حيلا ريفرنس تمبريتشر لانه بالاخر ريفرنس تمبريتشر ما بتاثر بشيء، حتروح لانه when you do this integral minus this one T برايم بتروح بضل لك الانتجرال from T1 to T2. اوكي. هلا مثل ما نحن قبل كنا نستعمل اوقات اليونت بير كيلو جرام واوقات اليونت بير كيلو مول، في عندنا تيبل تعطينا الريزلت بير كيلوغرام، في عندنا تيبل تعطينا بير مول بيزس الجواب بير كيلو مول. ساعتها كل شيء بيصير بار، يعني اس بار تي 2 بي 2 minus اس بار تي 1 بي 1 equals to اس 0 بار تي 2 minus اس 0 بار تي 1 minus r bar ln p2 over p1. هلا let us do an examples, okay, to see how to use this. يعني for example إذا قالوا لي the following: determine the change in specific entropy in kilojoule per kilogram Kelvin. أول شيء لأنه per kilogram هستعمل الكيلوغرام basis formula مش تبع البار. Okay, of air as an ideal gas undergoing a process from T1 300 Kelvin P1 1 bar to T2 1420 Kelvin P2 equals 5 bar. بما انه بعرف P1 P2 T1 T2 يعني اي فورمولا بدي استعمل؟ بدي استعمل انه S2 minus S1 هي equal to S02 minus S01. اوكي. شو كمان قلنا plus what؟ شو هو تاني term؟ R times ln
ln of
P2
P2 over
over
P1.
P1. اوكي. طيب اول شيء بما انه اتس
هي مش
for
minus.
air نحن بنعرف الار for air we replace it. اوكي رح هي 8.314 over 28 هيدي المولر ماس 28.97. اوكي بيبقى ومعنا البريشر P2 معنا البريشر P1 we replace. اوكي بليز انتبهوا على اليونتس. انتوا اذا بدكم ان كيلو جول بير كيلوغرام كلفن هيدي الار كمان بتستعملوها. اوكي you use the corresponding value in كيلو يعني 8.314. اوكي. وبالنسبه للبريشر هون فيكم تحطوا اللي بدكم اياه لانه they will cancel out، يعني فيكم تخلوها بار لانه 5 بار over 1 بار حتروح، يعني the ratio is 5. now بضل عندنا S02 minus S01. to get this we need the table. we need to go to the table. معنا two temperature T1 و T2. بنروح على التيبل بننبش على انتبهوا بالتيبل شو الانبوت على طول تتاكدوا من اليونت T in Kelvin. So I need first T1 300 Kelvin. I can look here. This is T1 equal to 300 Kelvin. What is S0? I read the value of S0. Okay, so I get 1.70203. I do the same here. And at the second temperature 1420. What is S0? 3.37901. Then I replace in my formula and I can get what is delta S between 1 and 2. Okay. Now, what if I have I want to use the other formula يعني تبع specific volume. Okay. هلا نحن مثل ما قلنا انه it depends in the case. إذا أنا عندي constant C فيني طلعها من الانتجرال بتصير ما بعوز tables. So if I have C constant no need to tables طلعها لبرا الانتجرال. And I say إنه S from T2 to V2 minus ST1 V1 equals CV ln T2 over T1 plus R ln V2 over V1 or in case I know P1 and P2 بقول equal to CP ln T2 over T1 minus R ln P2 over P1. يعني على طول انتم لازم تشوفوا بالجيفن شو قالوا لكم. اذا قالوا لكم treat CP and CV as constant to use these relations. اذا ما قالوا شيء use the tables. Okay. Now let us go back to the main purpose of this chapter. نحن we want to link entropy change to entropy production. تنعرف إذا أي متى عندي process reversible وأي متى irreversible. So until now نحن we defined entropy. نحن we defined ds as del Q by T for an internally reversible process. بس مش يعني إنه الأس ما فيني استعملها إذا عندي reversibilities. فيني استعملها اوكي بس بتصير دلتا اس ساعتها different than بس تكون دلتا اس different than integral of del Q over T يعني منه reversible يعني في irreversibilities. okay and we'll learn here how to search for entropy production. Okay, so let us see together what is the equation that we can do. First, we have that, as we said, in case it's reversible, then del Q is TdS. Okay, and in case it's irreversible, we'll get different results. يعني إذا بنعمل delta S وانتجرال del Q over T ما بيطلع لنا نفس الجواب. That's why, okay, we'll define now what is the relation between entropy production and entropy change. Okay. هلا إذا كان إذا بدكم reversible, we can always say whenever you have a reversible process شو فيكم تكتبوا؟ فيكم if reversible, you can directly say that delta S, so we can write that TdS equal to del Q, يعني the amount of heat transfer during this small variation ds. ساعتها integral TdS from point 1 to point 2 شو بتكون؟ equal to integral del Q يلي هي ال Q during process 1 2. اوكي، يعني بس تعرفوا انه عندي reversible process فيكم دغري تستعملوا انه Q of this process is integral TdS. ونحن بنعرف انه mathematically integral TdS هو الاريا under the graph. يعني منشان هيك we use a lot TS graphs لانه if we have reversible processes, the area under the TS graph will represent the heat exchange. Okay. Now, let us remember نحن شفنا إنه one of the main reversible cycles هو الكارنو cycle. نحن تعلمنا how to draw Carnot in PV, and now we'll see how to draw it in TS. Okay? ونحن بنعرف إنه for a closed system, what is W net? For a closed system, we have W net is equal to integral PDV. Okay, انتو إذا بتعملوا integral PDV, this represent what? It represents the area bounded by this graph. فبس يكون عندكم P function of V, the area will represent the work, the network. Okay, بينما بس يكون عندكم T function of S, if you get the area here, what should you get? You should get the total value of Q. Okay, يعني sum of Q can be given by integral TdS, and sum of W can be given by integral PDV. مشان هيك بنقول إنه graphically بس يكون معنا P function of V we can get the network، وبس يكون معنا T function of S we can get the net heat. أكيد إذا reversible، اتفقنا؟ لأنه إذا منه reversible we cannot say if irreversible ما فينا نكتب TdS equal del Q. This is wrong is irreversible. It's only valid, so this relation is wrong, is irreversible. Okay, it's only valid whenever you have reversible processes. ونحن بنعرف انه Carnot cycle depending إذا بدكم how we operate it فيكون power cycle وفيكون refrigeration or heat pump. يعني لاحظوا من الارrows إذا هون الارrows like this شو يعني؟ If I have these arrows, okay, نحن بالpower cycle شو بنعمل؟ We give heat at this stage to produce what? To produce work. Okay. We give heat to produce work. So this is the power cycle. بينما إذا بنقلب الarrows شو بيصير؟ بيصير على العكس. يعني نحن عم نحط work, we are putting work to the system in order to extract heat from a cold place, so this is Q cold, and to pump it to a hot place. إذا نحن عنا refrigeration إذا بتتذكروا ساعتها شو بيهمنا Q cold، يعني قد ايه we extract heat. So بنعمل ال COP هي Q cold over W. بينما if we have a heat pump we care for QH. So for a heat pump we put QH over W as COP. Okay. So you know all of these, but شو جديد هلا إنه for a reversible process we can say that sum of Q is integral T ds. Let us start to do some problems on this together. So we have water, initially a saturated liquid at 150 degrees, is contained in a piston cylinder assembly. The water undergoes a process to the corresponding saturated vapor state, during which the piston moves freely in the cylinder. If the change of state is brought about by heating the water as it undergoes an internally reversible process at constant pressure and temperature, determine the work and heat transfer per unit mass, each in kilojoule per kilogram. Okay. يعني هون هنا عم يعطونا process واحد اللي هو constant pressure and temperature when we go from point 1 to point 2. Okay. وبدهم إيانا نجيب ال work will heat during this process. We can do the analysis of this graphically and we can do it by calculation. إذا أنا برسم P function of V و T function of S from 1 to 2. What I am doing, I am heating at constant pressure, as they said. Since I'm heating at constant pressure, وأنا عندي phase change, حتكون the temperature constant والpressure constant. يعني أنا I'm inside the dome. Okay, so if you look at this graph, how you can find the work done? All you have to do is to say that the work done is equal to the area under this graph. اللي هي actually how you calculated أنتوا بتعملوا P times delta V, and P delta V represent what? The area of this rectangle. Okay. كمان الheat, how you can calculate the heat? You can say because it's reversible, you can say because we know that when you have reversible process, Q is integral TdS. And since the temperature is constant, شو بيصير بالtemperature? We can take it outside of the integral. So Q is equal to T times delta S. Okay, and this corresponds to the area of this rectangle here. So now all you have to do then is to apply these formulas. يعني you go to your tables, بتجيبوا what is V1, V2, you do P delta V, you get the work. You go to tables, you get S1 and S2 from tables اللي هن correspond to F and G. يعني هون this is very simple. This is SF at this condition, and this is SG at the corresponding temperature and pressure. Okay. So this is very simple. It's like we do before. We just go to tables, okay? We get S1, S2, we get then the heat exchange per unit mass by doing T delta S, and the work per unit mass is P times delta V. Now, the most important part in this chapter is here. What if my process is not reversible? If I have irreversibilities, what will change in my equation? The following will change. First, we said, if my process is reversible, delta S, which is the entropy change, will be equal to integral del Q over T, which is the entropy transfer. So this was the case if I have no irreversibilities. But if I have irreversibilities, يعني في what we call entropy production. Okay, so then whenever I have irreversibilities, these two terms will not be equal anymore. They will be different. And because I have entropy production, يعني delta S will tend to increase. So we say that the entropy change then will be equal to the entropy transfer, which is integral from 1 to 2 of del Q over T plus sigma. And sigma represent actually what we call the entropy production. And it's impossible to get negative sigma. Sigma is always larger or equal to 0. Okay, if sigma is equal to 0, what can we say then? Reversible process.
Reversible.
And if sigma positive means that we have entropy production, and then the process is irreversible. And never sigma can be negative. Sigma negative means then that we have something wrong. It's impossible. Okay, so from here, this is what we know from the Clausius statement, and now we related the entropy change to the entropy production. So if you want to determine what is the entropy production, what do? You have two states, 1 and 2. You go to tables, you calculate S2 and S1. Plus also you can evaluate what is integral del Q over T. I will take examples. And you compare the two. If they are equal, so the process is reversible. If they are different, then you calculate sigma, and sigma should be positive. It can never be negative. If you get a negative result, you say it's impossible to have this cycle. Okay. Let us do problems to practice on this. And if you remember, we used together in last chapter this equation to determine if a process is possible or not, if you remember. This term, اللي هو change in the amount of entropy contained within the system, هو delta S. So this is the change of entropy from state 1 and state 2, it's delta S. Now, the net amount of entropy transfer, so the entropy transfer across the system, who will integral dq over t, okay? And the entropy production, who is sigma? And this term should be always larger or equal to 0, and it's impossible to have it as negative. Let us try to do an example and see if we have reversible or irreversible process, okay? We have a refrigerant is compressed adiabatically in a piston cylinder assembly. بس يقولوا adiabatic process, okay? This means what? شو يعني بس يقولوا adiabatically?
Q
Delta Q
equal
equal to 0.
constant.
Yes, Q 0, okay? So Q is 0. In a piston cylinder assembly from saturated vapor, يعني they gave us state 1. State 1 is saturated vapor at 10 Fahrenheit. To a final, هلا don't worry, انتم ما عندكم English units, okay? بس انه this problem is very similar to SIN, so use the corresponding tables. To a final pressure of 120 lb per inch square. So we know the initial state, we know that it's saturated vapor at 10 Fahrenheit, and we know for the final state just the pressure, okay? We want to determine the minimum theoretical work input required per unit mass of refrigerant. To do this, okay, بس يقولوا لكم minimum theoretical، بس شوفوا هيدي الجملة شو يعني؟ تيكون أنا بدي أحط minimum work required، يعني I don't have any loss, I don't have any entropy production, okay? And we can demonstrate this together now بالformulas. بس يقولوا لكم من هلا ورايح this minimum، يعني شو؟ يعني I entropy production should be 0 to be able to do to put the minimum if you want work to achieve our goal. And we'll demonstrate together that the minimum work will correspond to sigma equals 0. How to do this? First, we say we are going from one state to the other, okay? We can go, إذا برسمها in TS diagram. And what is my purpose? I want to increase the pressure. صح? I can increase the pressure at constant entropy, or I can have entropy production. إذا صار في entropy production مثل ما حنشوف أنا وياكم هلا, S will be larger. يعني because entropy production will lead to increase of S. And how we demonstrate this in equations? Let us do it together. Okay? أنا مش قلنا I have adiabatic process. Let me write the equation and see what will happen when I have an adiabatic process. To start with, okay, you in any problem, write the energy equation. What is your energy equation? You have delta U plus delta kinetic energy plus delta potential energy equal to Q dot minus W. هلا هون إذا بدكم فينا نشتغل حنشوف بعدين إنه أو rate equation يعني dot أو فينا نتركها per kilo in kilojoule per kilogram, depending on what we have here. بما انه ما عطونا هون اذا بدكم rate, okay, ما عم نشتغل على rate equation, we can write the equation in the following form. اول شيء, what do we know? We know in general they didn't mention anything about kinetic or potential energy, so we can neglect them. Okay, they told us that it's in a diabatic process, so what can we do with Q? As we said, Q is 0. So what is the equation that we can write now from the energy balance? From the energy balance, we have that minus W over M, yani the work per unit mass, okay, is equal to U2 minus U1. Okay, so this is our first step. Now, second step, نحن قبل على طول كنا نكتب بس الانرجي بالانس, but now in addition to the energy balance, what should we write تنعرف مش هنا عم بيقولوا لنا بدنا نحط المينيمم ورك. المينيمم ورك طلعوا بهالايكويشن. minimum work correspond to what? correspond to delta U minimum, صح؟ So أنا I want to try to have delta U minimum, and since U1 is given, يعني U1 ما فيني ألعب فيها because I know state 1, I can just play with state 2. هنشوف أنا وياكم إنه we have several ways to go from 1 to 2. إذا بيكون إذا بيكون reversible process بتكون S constant. بينما حنشوف سوا بس نكتب ال second law of thermodynamics إنه بما إنه ال production of entropy على طول لازم تكون positive, يعني S2 أو بتكون equal ل S1 أو بتكون أكبر من S1. It's impossible to have S2 smaller than S1 لأنه ساعتها بيصير في عندي sigma negative. Okay, يعني to see what is delta U minimum, I should see what is the case of S, يعني what is the minimum value of S that is possible. نحن إذا بنكتب the second law of thermodynamics, what can we write? We know that delta S is integral from 1 to 2 of del Q over T plus the entropy production sigma. Okay? انتو بما انه adiabatic process, يعني what is del integral del Q over T? It's 0 because adiabatic. So what can we deduce? We deduce that the change in entropy, okay, is equal to the, in this problem, is equal to the entropy production sigma, and sigma should be larger or equal to 0. يعني مستحيل إذا case adiabatic إنه delta S تكون negative. Okay, so since we are looking for the minimum change in delta U, then the minimum will correspond to delta S equal to 0. ليه؟ لأنه طلعوا بالجراف. If I go back to the graph and do the analysis, okay, طلعوا بالجراف. نحن بنعرف إذا أنا delta S cannot be negative, يعني أو minimum بتكون 0, يعني I go straight forward like this, okay, أو delta S بتكون positive, يعني I do this. إذا بنروح على tables, we can see that if S will increase at constant pressure, مش نحن عندنا constant pressure process هون, we are dealing with P constant, okay. إذا بتروحوا على tables بتشوفوا إنه if P constant, إذا S will increase, U also will increase. بس أنا I am searching for U minimum, so U minimum will correspond also to S minimum. And what is the minimum possible S? مش نحن شفنا إنه delta S بتكون or larger or equal to 0. يعني minimum S بقدر أوصل لها هي لما تكون delta S is 0. So S2 minimum is equal to S1. Okay, and therefore for this case I can obtain delta U minimum. كيف بجيب S1؟ بقول إنه أنا if I go from 1 to 2 in isentropic process, S2 is equal to S1, and S1 is simply